Okay, so today we're starting a new chapter. It's chapter 11. It's our statistics chapter. It's the last chapter in the book, and then we will have finished everything in algebra. After this, I might go back and review some things. We'll do some projects, things like that, but this is the last chapter, so congrats, guys, you made it through. Okay, so this chapter is like tedious, but very real life. You know, if you decide to go into marketing, anything with business, if you decide to be a teacher, I mean, pretty much any job, you're always looking at data and analyzing data, which is all about what this chapter is about. So, you know, if you're one of those people, it's kind of like, oh my gosh, why do I have to learn this? You know, this is like the chapter that like everybody really needs to know this stuff. So, might take a little bit of time getting through this video. I do apologize for that. It's a tedious lesson, so it's going to take longer because of that. So I'll just try to go as quickly as I can. Get your graphing calculator out, you need it, or have the emulator ready for you, which we downloaded a few weeks ago. Let me know if you have any issues with that. Okay, example 1. Manuel plans to buy a new car with the gas mileage shown. To determine if the gas mileage of this car is good, he gathers data on the estimated city driving fuel efficiency in miles per gallon of several other cars. How does the fuel efficiency of the car he wants to buy compare to the fuel efficiency of the other cars he researched? Okay, so it looks like the one he wants to buy gets 26 miles per gallon, and then these are all the other miles per gallon of the cars he researched. So, you know, every car is different. Typically, smaller cars get better gas mileage than bigger cars. You know. All right, here we go. So it says, Manuel wants to compare individual values. So a dot plot is a good way to show that information. So a dot plot, let's review how to do that. With a dot plot, it's going to show all of the individual values. So what we're going to do is we're going to draw a line here. And be careful, you have to draw your numbers really small because I'm looking at my smallest number I have, and that's 25. I don't see anything smaller than 25. So I'm going to write a 25 under this line. And I'm going to cross it off. I like to cross off as I go so I keep track. The next is 26, I see. So 26. Sorry, what we're going to do is we're going to go back. Okay, we have 125, so we're going to put a dot above that. For 26, we have 1, 2, 3, 4 26s. 1, 2, 3, 4, so you put 4 dots above 26. Let's see, 27, we have 1, 2 27s. 28, we have 1, 2, 3, 4 28s. 29, we have 1. 30, we have 1. 31, we have 1. And then we don't have 32. We still need to write it here though. We can't just skip numbers. We don't have 33, we don't have 34. 35, we have 1. We don't have 36, we don't have 37, we don't have 38, we don't have 39, we don't have 40, 41, 42, 43, 44, 45. Okay, I just fit it. And we have 145. And everything's crossed off, so we're good. Okay, you can also count your dots and just see if it matches the amount in the table there. All right, what might account for the outlier? So first of all, this is where our data is clustered, okay? Data is clustered. This is where most of our data is. So this is where most of the miles per gallon gas mileage is, anywhere between 25 and 31. Then you wouldn't call this an outlier, it's not really that far away. This one is definitely an outlier because it's like way far away from the rest of the data, okay? So the reason this might be an outlier is, I would say maybe the car could be a hybrid or electric car. So it could be like one of those smart cars, while the others are gas vehicles. So typically hybrid cars get better miles per gallon. Okay, next. Example 2. Represent and interpret data in a histogram. The marketing team is about to launch a campaign for a new product that is targeted at adults aged 25 to 34 years. The team is researching the age range of viewers of a certain TV show to decide whether to advertise during the show. The data shows the ages of a random sample of 30 viewers of the show. Based on the findings, should the marketing team launch their campaign during a particular show? So 25 to 34 years is what they're thinking right now to basically this new product is targeted at people that are ages 25 to 34. So they basically want to look at where should I have my commercial on what, around what TV show. So like if you think about it, something like Nickelodeon or like Disney Channel, they market towards young children. So there's going to be like a lot of toys advertised. You know, if you're watching something like MTV, you're not going to see toys advertised because who's watching MTV? Well, 5-year-olds, 6-year-olds are not watching MTV. Teenagers are, college kids are. So that's why the products that are advertised during those shows go along with the age groups, if that makes sense. Okay, so now what we have to do is we have to create a frequency table. I just copied this frequency table from the book. So basically, histograms are often used to represent data over ranges of numbers. To create a histogram, first decide on an appropriate interval for the data, create a frequency table to organize the data. So my range is going to be from 0 to 4, 5 to 9, so all of these numbers are like 4 apart from each other. You have to make sure that your range is like the same every time. You can't do like 0 to 4 and then like 5 to 20, like you can't do that. You have to make sure it's like the same interval every time. So there's nobody between the ages of 0 and 4, nobody between the ages of 5 and 9. 10 to 14, there's 2 people, so I'm going to put 2 tally marks, and 14 and 14, okay, those are right there. 15 to 19, there are 10, so 1, 2, 3, 4, tally mark, 1, 2, 3, 4, tally mark, so that's 10. 15 to 19, that would be this one, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. 20 to 24, that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there's also 10 for that, so I'm going to do my tally marks. And then 25 to 29, there's 1, 2, 3, 4, and that's it. And then 30 to 34, there's 1, 2, 3, and then 35 to 39, oh, here it is. I'm like, where is it? I knew there's one. Okay, there's one. And there's nobody from 40 to 44. So that's what I'm talking about. This is a tedious lesson. You got to be careful. Use the frequency table to create a histogram. So what you're going to do is you're going to basically draw, it's going to look like a lot like a bar graph. Okay. For my frequencies, I'm going to go by 2s. So that's how often they come up. So 0, 2, 4, 6, 8, 10. I'm going to label this frequency on this axis over here. And then down here, I'm going to do 0 to 4, 5 to 9, 10 to 14, 15 to 19, 20 to 24, 25 to 29, 30 to 34, 35 to 39, and 40 to 44. Okay, So for 10 to 14, we had 2, so we're going to draw a bar up to 2. For 15 to 19, we had 10, so we're going to go up to 10. Make sure you connect all your bars. From 20 to 24, we also had 10. From 25 to 29, we had 4. From 30 to 34, we had 3, so it's right about there. And then from 35 to 39, we had 1, which is like here, okay? Which age group would be a good match for products advertised on this TV show? So most people are between the ages of 15 and 24. So really, that would be a good match for products advertised on this TV show is ages 15 to 24. So 15 to 24 years. And I can say that 20 out of 30 viewers, because this is 20, right? 10 and 10. Or about 67% were 15 to 24 years of age. Okay, next, example 3. Represent and interpret data in a box plot. So box plots, same thing as box and whisker plots. We have learned about that. We've learned about all these different types of things in 6th grade math. And I also taught you this last year. Okay, students at a local high school organized a fundraiser for charity. Caitlin, the student council president, announces that more than half of the students raised over $50 each. The amount of money raised by a random sample of 24 students is shown. Do the data, I feel like that sounds so weird. Does the data support Caitlin's claim? So we have all our data values here. And basically, anytime you're dealing with a percentage, so like more than half, that would be 50%, right? Or more than 50%. You want to make a box plot because box plots show percentages. So with the box plot, there's a 5-number summary. There's the minimum value, which is the least. There's the maximum value, which is the greatest. There's the median, which is the middle value. And then there's the first quartile, and there's the third quartile. So Q1 and Q3. So first we have to put all of our data values in order. So start like all the way over here and write really small. The first value we have is 25. To speed this up, I'm just going to write what they are. You would have to cross off one at a time for this, but to speed it up, I'm just going to write what they are. So 25, 25, 26, 27, 31, 32, 32, 36, 38, 42, 42, 45, 45, 45, 48, 49, 50, 50, 54, 54, 54, 55, 59, 68. Okay, so normally if I didn't give you that, you would have to put them all in order, cross off one at a time, you know what I mean? Okay, so now what we're going to do is we're going to fill this out. So the minimum value is 25, that's my smallest value. My max is 68, that's my highest value. Before we find Q1 and Q3, we have to find the median. So to find the median, you want to cross off an even number, the same number of numbers on each side. So we have 24 students here, so I'm going to cross off 11 on each side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so the median is halfway in between these two values. Okay, so 45 plus 45 divided by 2 is 45. So the median is right here. Okay, in between, so 45. Now, to find Q1, I'm going to take the lower half of the data and I'm going to find the median of that. Okay, so this has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 values. So I'm going to cross off 5 on each side. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And that leaves me with 32 and 32. So 32 is my Q1. I'm going to do the same thing on the other side to find my Q3. So this half of the data, I'm going to find the median. So I have to cross off 5 on each side. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 50 and 54. Halfway in between there, 50 plus 54 divided by 2 is 52. So that's my Q3. Okay? Now, let me show you how to do this in the graphing calculator real quick. What you're going to do is you're going to turn your graphing calculator on. Okay, let me see. Can we see this? Yes. Okay. What you're going to do is you're going to turn your graphing calculator on. Then you're going to go to Stat. You're going to press Edit. You're going to type in all of your values to L1. It doesn't matter if they're in the right order or not. I typed them in the right order, but it doesn't matter. You're going to type in all of your values. I'm not doing that with you because that'll take forever. I did this ahead of time. Okay? Type in all of your values. Just type in 25, 25, enter. 25, enter. 26, enter. So on and so forth. After you do that, you're going to press Stat again. You're going to go over to Calc. So arrow over to Calc. And that gets you to 1 var stats. You're going to press Enter. I have to press Enter a few more times. You might not have to. And it gives you all the information you need to know. So X bar, that's your mean. This stuff we're going to learn about in a few more sections. This is standard deviation, variance. N equals 24, that means there's 24 values. Your min is 25, your Q1 is 32, your median is 45, your Q3 is 52, and your max is 68. So it gives you everything you need to know. So you don't have to do this longhand forever. Had to show you once. Now use your graphing calculator. So much easier. Pause the video and practice that. Let me write down the steps for you here. So you press Stat, Edit, enter values in L1. Then you press Stat again, arrow over to Calc, and then 1 var stats, you press Enter. Might have to press Enter a few times, and that gets you all your information. Okay, so basically she said that more of half of the students, oh, we didn't even make our box plot yet. Okay, sorry. We have our values, now we're gonna make our box plot. This is the easy part. I'm gonna go by tens, so I'm gonna start with 20, and I'm gonna go all the way up to 70, because my lowest number is 25, and then my highest is 68. So 20, 30, 40, 50, 60, 70. Okay. Now, I'm going to put my minimum at 25. That's right about here. My max, I'm going to put a dot at 68, which is right about here. Then I'm going to put my Q1 at 32. That's a line like that. Q2, or the median, is 45. And then Q3 is 52, which is right about here. Then you connect these to make a box. This should be a review. We've done this before. And those are your whiskers. Okay, that's your box plot. So remember, this is 25% of the data from here to here. Okay, from your lowest value to here. This is 25%. This is 25%. And this is 25% of the data. Okay, so this is your middle 50%. So from Q1 to Q3 is your middle 50%. So basically, more than half of the students raised over $50. No, that's not right. Half of the students raised $45 or less. Because if you look at this, 45 is your middle, and then half of them, this 25% and this 25%, that makes 50%. The lower 50%, half of the students raised less than 45. If 25% of the students raised over how much money? Okay, so 25% of the students raised over $52, because this is the upper 25. Okay, last but not least. All right, Helena's dance team scores 68 points at a competition. The scores for all of the teams that competed are below. Helena wants to know what place her team finished. Should Helena use a dot plot, histogram, or box plot? All of this is super important, okay? She's definitely going to use a dot plot for this because she wants to display all of the individual values to figure out where she placed. So we're going to make a dot plot. The lowest score is 65, so I'm going to put that here. And then we have to work our way all the way up to 90. So write really small, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, oh boy, 85, 86, 87, 88, darn, oh my goodness, 89, 90, that's a problem. Yeah, write a little bit smaller than I did. Okay, 65, there's one of those. There's two 66s. I did this ahead of time, so I know. You would have to cross off in the table to figure it out on your own. There's 168, there's 175, there's 179, there's two 80s, there's three 81s, there's two 82s, there's an 83, there's an 89, and there's a 90. Sorry about that. Okay. So basically, she wants to know how her team finished. So if she got 68 points, she placed 13th out of 16 teams, okay? Because this is first place, second place, third place, all the way down. So she placed 13th out of 16 teams. What data display should Helena use if she wants to know what percent of the team scored higher than her? So if you're dealing with percentages, you want to use a box plot. Okay, that's it. I tried to go through that as fast as possible. I know it's a lot. I know it's tedious. But yeah, that's kind of what this chapter is like. So sorry it's a long video. Tried my best to go as fast as I could. All right, have a good day.